Alright, so let's do some notes for today. Today we're going to start talking about writing linear functions, writing and interpreting linear functions. So if you got a sheet of notebook paper, let's title that Writing and Interpreting Functions. Alright, and you might be thinking to yourself, hey coach, we've been doing that for a while, right? That's y equals mx plus b, that's slope and y-intercept, which is true, but not every problem is going to give it to you like that. Not every problem is going to give you a slope or a y-intercept or even possibly x's or y's. You might have to take a regular situation and make it look like a function. Alright, so that's what we're going to look at. So I'm going to give you a couple, actually three different kinds of examples. And the first one is, what if I give you some ordered pairs? Now this is kind of a review. So like my ordered pairs would be, let's for example use 0, 1, 2, 5, or 3, 7. Alright, so how would I go about writing a linear function? Well, this is kind of like what we did the past couple lessons, except I've given you some extra data. Alright, because remember, I want the m and I need a b in order to be able to write this linear function. So if I've got 3 points, then I can find the m by using y2 minus y1 over x2 minus x1. Alright, well, let's pick 2 points. It doesn't matter which ones we choose. We could actually choose this one as x1, y1, and this one as x2, y2. Alright, let's plug those values in. y2 is 5, minus y1 is 1, over x2 is 2, minus x1, which is 0. We do a little subtraction to get 4 over 2, and that reduces to 2. So that's half the battle, right? I got the m, I got the slope. Now, I wonder if I have a b. If I don't have a b, then I've got to use another formula. So like point slope formula. But if I look at my 3 points here, do I have b? Check out this first one that I used. I know I've labeled it x1, y1, but ignore that for just a second. And I have a point that is 0, 1. Well, something special about that 0 right there. That 0 makes it an intercept. In fact, that 0 makes it a y-intercept. Well, a y-intercept is b. Remember? Okay? B stands for your y-intercept. Alright? So in this case, the b is just the 1. Well, if I have the m and I have the b, all I need to do is write it out. Y equals mx plus b. The m is 2, the b is 1. This equation is y equals 2x plus 1. Okay? Now, it's not always going to be that easy, and it's not always going to look like ordered pairs. For example, what if I gave you a table? Let me get a new sheet of paper here. Here's a table. And at the same time, what if I don't give you x's and y's? Let's say I have a situation, this will be example number 2, that has hours worked and the wages earned. So like if I work, let me see another piece of paper here. Let's say if I work 10 hours, I earn $55. And if I work 8 hours, I earn $44. Or if I earn 15 hours, if I work 15 hours, I earn $82.50. Okay, these are all money. These are all hours worked. Okay. Now I know right off the bat you're like thinking, what are we doing here? I thought we were doing y equals mx plus b, and I have h and w here. Well, the thing about math is you can translate any situation into math stuff. So yeah, I know this says H and W, but really in any table, the left side is always X, and the right side is always Y. Now again, remember, I need slope, and I need a y-intercept. Alright? Well, I can find slope by doing either the slope formula, or if it's put up in a table like this, I can easily do change in y over change in x. This is the y value, so how do I get from 55 to 44? Well, that's a change of going down 11, correct? Well, the change in x would be going down from 10 to 8. That would be a change in negative 2, right? That would be subtracting 2. So my slope is actually a negative 11 over negative 2. And that reduces, actually it doesn't really reduce, it reduces to a positive, but it's also like saying it go down $11 for every 2 hour, okay? Or since I'm dealing with a real life situation, I'm going to need to make that a decimal. 11 over 2 reduces to 5.5, or I could say that's like 5.50 an hour. Okay? Well, that's part of my battle. That's my rate. That's my slope. Alright? And that's going to need to go into my equation. The next thing I need is what happens after, like for the y-intercept. How am I going to calculate the y-intercept? Alright, well, remember the y-intercept is where the line crosses the y-axis. It's also where x is 0. Or if you think about it in this frame of mind, like in a table, how much am I going to make if I work 0 hours? Alright, well, if you think about it, I worked 8 hours and I earned $44. And I just told myself, or we just discussed, that my hourly wage was $5.50 an hour, right? Well, is that $44? Is that what I earned for making or for working 8 hours? And so sure enough, if I do 8 hours times $5.50, that is $44. And the reason why I'm saying that is because if I subtract that, okay, if I subtract that 8 hours away, I'd be at 0 hours. Agreed? And if I work 0 hours, if I subtract that 8 hours worth, I subtract that 44 away, subtract that 8 away, and then subtract the 44, that's going to be $0. Alright, now remember, I told you to do this because you need to find a starting point. How much money did I earn if I work $0? What's the value of our wages when you work 0 hours? That's your y-intercept. Alright, that's the value of y when 0 is x. That's the y-intercept. Well, in this case, if I work 0 hours, I'm going to get $0. So my linear equation here is going to be W is equal to 550 times H. Okay? Try it out. See if it works. We're going to do some problems on this tomorrow in class.